Well, good morning and welcome back to the little garage full of machines here in Walla Walla, Washington, and I'm your host, Dee Dee. And what I'm going to show you today is grinding the jaws on 3-jaw chucks. And I'll give you some background on my experience on that, and it's from hydraulics years and years ago and doing it for years, working on hydraulic cylinders and other actuators that use seals. Now, one of the guys, the hydro guys I call them, now my job's just to remove metal and to do it as accurately as possible. I'm not a hydrostatic expert, but I do know my way around the machine shop and the hydraulics end of it. So one of the guys I did work for, he would tell me, he goes, on simple O-rings and stuff like that can be critical. And he goes, on this O-ring, I want 10,000 squish. So if I'm cutting a groove for that O-ring, it's got to be pretty accurate. And the maximum error that I think should be allowable would be about 3 thousandths. So if the chucks start running out, and I'm talking about specifically 3-jaw scroll chucks, runs out more than 3 thousandths, then it should be taken care of. And a lot of people in other industries aren't used to doing that. In fact, on the stupid machinist forums years ago, I don't know where these people come from, but they'd say, oh, a 3-jaw chuck, when it's worn out, it's a boat anchor. Well, maybe so. But in the industry I worked in these rural areas in particular, 3-jaw chucks are very expensive, and even now, you know, a good quality 3-jaw chuck's going to be over $1,000 even for an 8-inch. And I have a 12-inch example of a Bison with a 4-inch whole steel-bodied 12-inch chuck. Is like $3,800, and it can't. One of those came on this Axelson here, and I had to grind the jaws on it, but the rest of it is in good shape. And so that if you're going to grind the jaws on a chuck, you want to take it apart and clean it and inspect it. And there's a couple of problem areas that might need to be taken care of, and I'll try to remember to be thoroughly explain some of that. So, okay, we're back to the chuck at hand. And I'm going to go through some basics before you grind the jaws, okay? So I got this little 4-jaw here, 4-inch 3-jaw here. And I mounted it to this back plate that I fabricated. I did everything I possibly could to fit this back plate correctly. I believe I have it very good, and we'll do some tests on that a little later. But number one, I'm going to say, in the last video, I changed this from a back mount to a front mount by drilling these holes in the front for the screws, okay, to go in. And it's got a tight shoulder, how you machine a shoulder to go into the back of the chuck. So it really fixed this in place, okay? It can't be shifted. So doing some preliminary tests, I got a dial indicator on the outside of it here, and it run better than 1/1000ths, actually better than 0.5 of an inch. Okay, now that's the outside. That's the radial runout. And I checked the front of it, and that would be the axial runout is the same. So the chuck body is true. Now let me get this onto the shaft here. Okay, try not to get too tangled up and stuff. Yeah, you can see that. So I'm going to put the dial indicator on the shaft. And I checked the pinions. There's 3 pinions on this. And so I went around and tried tightening the piece on all 3 pinions. And I chose the pinion that showed the least run out. That means you're going to be grinding the least amount off the jaws, okay, using the chuck or the pinion to tighten the part. Let me get this. And also, this chuck hasn't been used for a long time, and I just cleaned it out in the last video. So I worked the chuck. I opened it, I closed it, I tightened it on various materials and rings, you know, opened the jaws on rings and tightened it. And so I got it set so I think you can see it. And there's slight damage on the jaws that's visible. This is a used chuck off eBay, of course. So what I'm showing here, run out near the jaws, is about 3 thousandths, okay? That's about 3 thousandths. That's not too bad, really. Okay, now I'm going to move the indicator outward. Let me get that cable in a good spot there. I'm going to move it towards the end. Now this is an accurately ground shaft. It's a counter shaft out of a transmission. The runout's actually improving a little bit on this. Let me back that up here. Get that settled in. That improved 1 thousandths or so. Okay, you can watch this. Okay, there's the low point. And it looks like just about 7 thousandths run out on the end. And that improved a little bit by just working the chuck a little. It's really a tight chuck. There's not a whole lot of deflection. Yeah, about 7, 8 thousandths. That's not bad. But we're going to make it a little bit better. Okay. Let's see, get that right there. Okay, we'll get that out of the way for now. Okay. So we're going to take and grind those jaws. I'll get that bar out of there. And I'm going to use a device, this device here. I'm going to put that on the jaws. Like so. Okay. Now I'm going to start tightening the jaws. And let's start getting that just a little snug, and I'll explain some things. It's not complicated, but there's a lot of little things, okay? Okay. So what this consists of is this outer ring holding these smaller split rings here. And the rings are split, and I'm going to move it towards the tip. Now, the reason I'm doing that, it's logical. Little bit right, yeah, that's looking pretty good. See how I can shift that at this point? You want to settle it in, get it settled in. Now, I'm moving it towards the tip of the jaws because when you're using chucks, they'll start losing contact at the tips because you're grabbing a lot of short things and stuff like that and tend to wear the tips out. So if you move this device, this loading device, more towards the tips, the little bit of slop in the jaws and everything, as you tighten it, will hold the jaws away a little bit, just a little bit. Now you might have to adjust this, but since it holds the jaws back, they'll get ground less. Okay, so if you move this all the way towards the body, as far as it go, I got the screws kind of in the way because I always grab the tips. Then it may cause the jaws to be ground a little too much at the front. But what happens, what's ideal, is as you're tightening this chuck, the tips will grab first, and then as you tighten it, the slop in the chuck will allow the rest of the jaws to the back part of the jaws to start to grab. And what that does, it's kind of doing a pinch rather than a push. So if it's a little bit bell mouth towards the outside, it's going to want to push small parts out. And we want the opposite. We want it to hold parts in. So it's a very subtle little situation. So I'm going to get this right in there and start tightening it. And I'm going to move this. Now, I got these screws about even, and it doesn't matter if this outer ring runs out a little bit, just as long as it's fairly close. And it's like a milking stool and an orchard ladder. And what those have in common is they sit on three legs. And three legs will sit on uneven ground. That's why orchard ladders have that one leg out the back, and that's the reason milking stools have three legs, because on soft floors and stuff like that, a four-legged stool will rock, and a three-legged stool will find home. And so with this three-jaw, and those rings, and everything's kind of close, it equals itself out. And I've had people say that, oh, that's not perfect, it's not going to work. Well, it does work, and it doesn't have to be perfect. When I first encountered this at a hydraulic shop, the device was crudely made out of just pipe. And thin pipe, and I don't have a bunch of pipe around. It's hard to find at the scrap yards here anymore. So I had to machine all this stuff, okay? And it actually makes a more robust device, but it doesn't have to be this fancy. It can just be pieces of pipe, and it'll work. So as you tighten this, you want to keep moving it, and you can tell. See, I can just wiggle those rings all the same, and then you get it a bit tighter, okay? About like you're gripping something. And then see, it won't shift, but you move it and find a good home for it, okay? Then you're set. Okay, now the next part of this, I will take this out. And we'll look at the chuck itself. Now, that device was actually showed on a World War II era film of American Industry Goes to War. They show that device on a chuck, likely at a chuck manufacturing company. Okay, now we're going to talk about the center hole. If you look, here's the center hole of the chuck here. It's a little bit over 1 inch. So when we grind these jaws, we're going to use that center hole and rotate this thing in until the jaws, you can feel it with your finger, piece of metal, that jaw is protruding into that center hole just enough so you can grind it, okay? So there I can feel that the jaws are just sticking in that center hole a little bit. So you can grind the jaw, the full length of the jaw, without hitting the chuck body. Now let's look at the chuck. Now at that position, if you look at the radiuses on the outside gripping surface here, it's a perfect circle almost. And then the jaws themselves here are radiused. Okay, this way you can't grind these in a surface grinder. And I don't know if you can see, there's a little bit of damage right here that's causing that run out. So this is a used chuck. Let's see if I can get a little more light on that. Just a little bit rough there. Let's rotate it around. It's just a little, that one jaw there, it's kind of got a ding in it. You can see on this one too, there's a little bit of a ding. You can see towards the back, the factory grind, and up the front, it's a little bit goofed up. There's like a ding right here. And I'm not gonna, it's fairly deep, I'm not gonna worry about getting it all out, but we'll see. So, okay, so I got the jaws here protruding past the center hole here. We're going to have to run the stone back all the way back into the body of the chuck here, then bring it back and grind the full length of that contact there. Okay, let me grab a ring, bunch them around here if I can only find them. Okay, here's kind of a heavy ring. Now, if you want to grind this step here on the outside, then when you're using that, then you're expanding the jaws out to grab a ring like this, see? And here, let me go ahead and do that. Okay. So to grind these steps here, you want to use a thinner ring. You'd put a ring here, then grind this step here. Then put a ring here and grind this step here. But the jaws will be in the same position here, see? You can't use that. This device here is only to grind this surface here. To do these other surfaces, you're expanding and you can use rings. And this doesn't have the outside grabber jaws. And on that chuck, you have to use rings too, except for you can use this device to grind the step which would be at this end here. So otherwise you use rings, but you can, people do it, like put a ring in. I'll go ahead and grab this. Okay. So I got that grabbed. Now you can't, or you can, but you shouldn't, use a ring and grind the jaws. I see people do it. It may get you in a better spot, but all the pressures are on the opposite side of what you need. On the scroll, on the teeth, on these jaws. So to get this the most accurate, you have to use pressure the way this thing's going to grab. Okay, you can only use a ring to grind these outside pieces. Okay, I think I explained that best I could. So we'll use that device, and I'll bring the jaws so they just enter the bore, and install that. Okay, I'll be back and talk about the grinder. Okay, the subject is jaw grinding for scroll chucks, 3-jaw scroll chucks. And this is the grinder that I fabricated as a tool post grinder. I can actually even use it in this configuration for internal grinding on the cutter grinder here. And it works really, really well. I've got it running just about 14,000 RPMs, as I remember. Maybe a little slower. And what I want to tell you is I'm using a point here, but I'm dressing it. And maybe I can show you real quick what I'm talking about here. Let's get this going. So I'm dressing the back part of this away so it does not contact, see? So the only part that's going to contact the jaws is the forward part here, just about a 1/4 inch, 3/16 or a 1/4 inch. So with this dressing stick, I'm just knocking back the rest of this point so only that little spot there contacts, okay? It helps with chatter and things like that, and you don't need full contact of that stone. So this is my rig for doing that, and I fabricated the whole thing, of course, and it works really quite well, really quite versatile. Someone commented that it's not good to drive something like this where I have the drive belt in front of the bearings, and all I gotta say is check out the redhead attachments for lambda surface cylindrical grinders. They work exactly like that. So that is viable. It works really good. Running with a flat belt, it's running smooth at about 14,000 RPMs. And that's what I'm going to use to grind the jaws. Now on larger chucks, I'll hook a bigger wheel in here, but that's a very small chuck there. It's a 1-inch bar in there, and it's got slightly over a 1-inch hole. Okay, so that's the grinding setup. And we'll continue. I hope you enjoyed this video. I've had to reshoot a few scenes because I inadvertently unplugged this microphone, jockeying myself around this machine. And that's the way it is. Okay, we will continue on and grind the jaws true in this chuck. Okay, now this is the final tightening. And I got this piece of steel here that's a mold ejector pin, but it's got a little shoulder on it. And I can stick it back here in the chuck body and pull it forward and feel that it grabs the jaw. So the jaw is protruding a little more than the bore in the chuck. Okay, now I've gone around and I've snugged these and got these pretty even. As far as how this thing sits, and it's good. I'm grabbing it, and then the final tightening is right here on the pinion that showed the least run out. Okay, so I got it just snug there, pretty tight, and that will get it more in the ballpark of where it is when it's cutting. And so the next step is I'll take and ink the jaws here. I'm probably going to have to use a skinny pin in there too, but I can get the front part of them. I'll get a skinny pin in there and get the back, and that'll help visualize if you got the things totally ground or not. Okay, so I'll ink those a little bit more. We'll get the machine going and we will grind. Okay, this wheel or grinding point is dressed, and we'll give the jaws a little bit of a grind and see how they're progressed. And the grinder is on. Okay. Okay, I'm going to ease it in. Okay, got some light sparks there. We'll see how it's going. So far, so good. Okay, I'm going to take a look at the contact real quick. Okay, I'm going to ease it in a little bit. About 1,000. just keep going on it. Hold on. It's looking okay. I was going the wrong direction though on the workpiece. I don't think that hurt anything. But the workpiece direction should be against the stone direction. I don't know if you can see the end of the stone. That's what's contacting it. Just about a 1/4 inch there, and I got the rest of it dressed back. I think that stone's running something like 14,500. A little bit slow for that size. Almost looks like it needs a little more work on the very tips here. A little bit of damage to one of those jaws. Give that a check here pretty quick. The jaws are looking like they're getting a good finish on them anyway. Okay, I'm going to give that a test. Okay, got that big loud motor off there. And where is that wrench? Right here. Got a piece of canvas I'm putting down to help protect the ways. Okay, we'll set that aside. And we'll find the rag here, get some of that grinding dust off. Do I have that neutral idea? Hope you can see those jaws, they're looking very nice. Okay, yeah, they look good. So we'll get that test bar in there. Get this backed off. I gotta open that up a little bit. There we go. Didn't want to disturb that setting with that stone. Kind of burnish those jaws just a little bit here. I'm going to rotate it towards the rear a little bit until it grabs. And I'm going to get on that pinion that I initially tightened this with. Okay. Find a dial indicator. And see what we got. Okay. Let's pull this on around. Got a microphone cable here to get loose. There we go. Okay, so we got an indicator on there. I'll set it right on that tin. And what do we have? I'm going to put it on 0. See, the indicator's working. Okay. Maybe just about a half run out. Okay, let's move this towards the end of the bar here. Looks okay. Let's see if we got some improvement. Remember, it was running about 8 thousandths. And we got that down to 2 thousandths. Now that's a little high. Let's see if I can push it true. Okay, pushing on it. Got it within about a half thousandths true there. Hold on, let me move this back over. Now again, this is working. It's not stuck. See where we're at. We were at 3 thousandths. It's actually better than a 1/2 thousandths, I believe. It's probably within a couple of tenths. And that's plenty good. Okay. We'll try for repeatability. Let's get it over to the jaw, or the pinion that appeared to be the best one to use. Okay, hold on. A little bit snug there. Okay, let's try to reset that. Okay, get that a little closer. Do the same test. Okay. Looks like it's repeatable within tenths, I guess, huh? Well, that's right on 0. What do we got? It kind of just moved over on itself. It's within a couple of 10 thousandths. Let's get it to the end of the bar. See where we're at. See, it's working. One and a half. Maybe 2 right at the end. Let's push down on it. And see what happens. I think it went the other way. I can't complain about that run out. Just pushing on it. Brought it within 1 thousandths. Now that's pretty good, 8 inches out. Running nearly dead true here, 8 inches out, running about 1 thousandths. Who'd guess? Okay. Hey, thanks for tuning in. I got one more little test to do and we'll check that out, okay? Okay, now I fabricated this back plate out of cast iron, a rough casting with a lot of scale. And I only used 3 pins. And I've mentioned before on these earlier lathes that they didn't grind the spindle in place. And it has, within Dean Smith and Gray's specs, it has less than a 1/2 thousandths run out on the spindle face, which is somewhat actual less than 4/10 thousandths. But that means I have to index the plate or it won't return exactly the same. And I haven't done this test. 1, 3, and 5, because there's only 3 pinions or 3 studs. Okay, 1's loose. See if I can get that over there. There it is, it's loose. Now I'm going to pull it loose. Okay, and I'm going to return it, but I do have to return it on the same stud. Now let's lock it in. 1, This is 5. Here's 3. Now I'm going to go over them and get them tighter. 1, 5, 3. Just about the same tightness. I'll get these blocks out. I didn't want to drop it on the ways. Okay, let's get the dial indicator on here. We'll see if it returned. Get that cable unhooked there. Let's get it on 0 and see if we picked up any run out removing and installing this. Well, what do you know? No run out problems. Now, what that means when I fit these back plates like that is that I can remove a piece of work in a 4-jaw chuck, for example, throw in a 3-jaw chuck and do an emergency job, toss the 4-jaw chuck or a faceplate or any of these attachments, of 13 spindle attachments that I have for this, will return exactly to 0. That's important. Now, the way I did that, there's a lot of different thoughts in schools, but the way I do this is I make that contact of that taper lightly, and then it's like the taper slightly tight, and then it locates it, and then it pulls in tight. There's no gap here with the cam lock studs. Okay, so I test it with ink with the studs out. I put ink on the taper, bring the thing up and rotate it and make sure that there's contact with the ink. Rather than it being loose on the taper, which will cause it to shift, or too tight, which will leave a gap and could cause it to actually run out, in my experience. So this is how I maintain accuracy in here. And you can see I removed it, replaced it without appreciable change in the run out. I double tested it. It's factual. Okay, have a good day. I'm going to take Chloe over to the duck pond. Talk to you later.